So here is what happened. I told you that when you want to see things that are farther away from you is called distance object, then your lens has to flatten. It is due to the ciliary muscle relax. Remember I told you that there's something called sonnular fiber. So this black thingy here that is connecting the sonnular fiber with the lens, this is called the that's connecting the ciliary muscle with the lens because sonnular fiber. Z-O-N-U sonnular. A-R. Okay, I'll write here. This is, I don't have enough space there. Fiber. Okay, and as you can see that when we see object farther away from us, the so-called distant object, then the lens will become flattened. On the other hand, when we want to see a near object, we call it proximal object, then the ciliary muscle will contract, and then the lens will become more rounded. Oh, they call it suspensory ligament. Yeah, it's the same thing. Sorry. Sonnular fiber and suspensory ligament, they are the same thing. It's just a different term. It's the same, okay. And then near object. Near object, we should call it proximal object. So because distant object, and then we have proximal object. Proximal object. Okay. Sense of vision. There's a visual pathway to the brain. Since you are not taking anatomy or physiology, I'm not giving you the visual pathway. But photoreceptor, this is something that you need to know. Photoreceptor, we have two types in our retina: rod cell and cone cell. So rod cell is sensitive to light. That's why it is important for night vision, meaning that when we at night we see things with rod cell, and the photopigment is called rhodopsin. You may consider rhodopsin is a form of a retinal. Okay, one form of retinal. It is provide peripheral vision. Why? Because the rod cell, they are usually located at the surrounding or the peripheral of the retina, and it's for motion detection. Yes, that's why when you see things, when something is moving on the side, of your so-called visual field, it is easier to detect. But if it's something that's moving in the center, it is more difficult to detect. On the other hand, cone lights, they are active by bright light, so that it is for light vision. Meaning that we use cone cell to see things in daytime. Allow for color perception. Yes, the reason it is for color perception because we have three types of cone cell. Each type of cone cell can basically we have three types of cone cell, and then they detect for blue light. One type detect blue light, one type of cone cell detect green light. One type of cone cell detect red light. And then that's why they are for color perception, and most of the cone cell, they are in the, guess what, fovea. Remember I told you that fovea centralis, they are mostly located in fovea centralis. Fovea centralis, they are for color perception. So that's pretty much it. Okay. So color perception, I told you that cone cell can detect 3 types of color: red, green, and blue. This is what we'll further explain it in this slide here. The red one, we call it L cone, because L, they absorb long wavelength. Long wavelength, okay, from approximately from, you said it from 564 to 580. 564 to 580. So they are just talking about the peak here. Sorry, I cannot draw a vertical line. Then the M cone, the medium, 534 to 545. Let me see if I can draw. Okay, approximately here. And then the S cone, short one, absorb the blue light, 420 and 400. 420 to 400. Can I draw a straight line? Yes, this is a perfect straight line. Finally, I can draw a perfect straight line. Okay. Because different cone cell, they absorb different so-called wavelength of the light. Longest wavelength is the red light, and then so-called medium wavelength is the green light, and then the shortest wavelength is the blue light. So that's why we have 3 types of cone cell. This will be the interest of some people, some student, colorblind people. They have defect of red or green photopigment. That's why they cannot see red or they cannot see green most of the time. So as you can see that, okay, cone cell, this is cone cell. Okay, cone cell looks like a cone, rod cell looks like a rod. Okay. In the outer segment here, you see a lot of band. This band, they're the disc. Inside the disc, they have the chromophore, which is the, for example, in the cone cell, not cone cell, this is a rod cell. In the rod cell, they have rhodopsin. In the rod cell, they have rhodopsin. Basically, it is made of a retinal. Remember, retinal comes from vitamin A. So you can see that in the rod cell, we have a lot of this disc. They are the rhodopsin disc. The disc has rhodopsin. The purple dot here, this purple dot, they are the rhodopsin. They're on the disc. And then what happens is that when the light ray go through the retinal molecule, then you open up ion channels, or you close the ion. You close the ion channel. When you close the ion channel, then well, I don't want to go into too much of the anatomy to confuse you, but I went through this in my physiology class. Well, because they are physiology students, they're supposed to learn the difficult stuff. So I just want you to know that, okay, when light goes through the rhodopsin or the retinal, okay, the chromophore, then it will cause changes to the retinal molecule, and then because of the changes of the retinal molecule, then the photoreceptor can signal to other cell to send a signal to the brain. Basically, that's the oversimplified version. Okay. Okay. The following is mostly anatomy. It's just pathway, meaning that what kind of structure the visual information go through in the brain. So of course the exit of the retina, the exit of the eye is the optic nerve. Okay. Optic nerve, they will connect. That means okay, from left and right eye, from let me see, from left and right eye, they will connect. The points of connection is called optic chiasma. So optic chiasma is where the left optic nerve and right optic nerve connects. So after optic chiasma, then it will split again into left and right optic tract. Okay, it sounds very okay. Optic nerve, left and right, right. Optic nerve will join. So the two optic nerve, left and right optic nerve, will join together to form optic chiasma. And then optic chiasma will split into left and right optic tract. Optic tracts, okay. It says that what fiber from the right half of each retina join together to form the right optic tract. Okay, that's true. Okay, from the left half of each retina join to the left optic tract. That's true. And then the optic tract will go through the hypothalamus. Really? Optic tract? That I'm not so sure. This one? Hypothalamus, I'm not so sure. It should go through the brainstem. Hypothalamus is mainly for controlling your endocrine system. The optic tract go through the brainstem. There are some brainstem nuclei, okay? And then yes, it will go to the thalamus, the nuclei in the thalamus. Let me see. Hold on, let me double check. Okay, I'm wrong as well. It shouldn't go through brainstem. That's for our brainstem, but hypothalamus, and I don't think it will go through hypothalamus, but it says that hypothalamus. Well, that I'm not so sure really. I don't think it will go through hypothalamus, but it will go through the thalamus for sure. So from the thalamic nuclei, you go to the optic radiation. That is correct. From the thalamus, you go to optic radiations and then to visual area. Visual area, it is in the occipital lobe. Oops, there you are. occipital lobe. Occipital lobe is at the back of our head. It is where we call it primary visual area, V1. Primary visual cortex or primary visual cortex. Primary visual cortex or primary visual area. So that is the V1. V1 is located in the occipital lobe. Yes, you can see that it is a good outline here. So the left and right optic nerve will connect at the optic chiasma, and then after optic chiasma it will split into two optic tract. Optic tract will go to the thalamic nuclei. That's why I think that it should not go to hypothalamus. And then from optic nuclei, you go to something called optic radiation, and then from optic radiation, you go to the primary visual cortex. We should call it primary visual cortex, V1, primary visual cortex, V1. V1 is located in the occipital lobe, which is the back of your head. 真係好強。